Perhaps you might remember from about 5 years ago, there was a movie out. It was produced by Al Gore. It was called An Inconvenient Truth. It was about what he called global warming, and it really did set things in motion to make people concerned about their climate. Well, you're going to hear today on this Access channel from a man who studied this global climate change for a great number of years, and he's also used a new science called system sciences, which is based on the balance of everything in nature and on the planet, calling the planet a living entity rather than a collection of rocks, trees, people, dogs, and dolphins, or things like in water and such things as that. So it's a balanced living entity. And this is the science called system sciences. It's been around for a few years, and he's going to explain exactly what this system science is all about, and it also entails the belief of the Earth as a Gaia system. Now, of course, we all heard about Gaia being the goddess of the earth from a Greek mythology. Well, this really has nothing to do with that. This is not a religion. This is a science, and a very sound science indeed. And in this thing, Alder Stone-Fuller is going to give us a lecture with a lot of illustrations about what this science is and just exactly how this science is going to affect our climate. Now, you're hearing this on Access Television, which I don't even believe I've ever seen anything like this on the corporate-controlled media. I keep pounding on that corporate-controlled media because all those national networks and the cable companies, that's exactly what they are, corporate-controlled. They don't want you to know. If you think that Al Gore had the inconvenient truth, listen to this truth. And it's not meant to scare you, but it is meant to warn you of what is coming, and when it comes, it will come very rapidly, and there won't be an awful lot of warning in, according to Alder Stone-Fuller. This is going to happen sometime in the next 1 or 2, maybe 3 or 4 decades, and it will happen very rapidly. So this is, he's had so much information, had to put it into 2 shows. So this is the first show, and this show deals with the systems sciences and the geophysiology, that's the general health of the planet, and he explains how that all works. And in the next show, you'll hear about the climate change itself and how it will come about and why we should be concerned. And according to Alder Stone-Fuller, the tipping point has already been reached. We only now have to wait for the results of, we're not blaming the people for causing this or any one thing. It doesn't matter whether it was a natural cyclical thing or whether our CO2 emissions caused it. That's not the point. The point is things are set in motion, they're going to happen, and we must be prepared. So I present to you Alder Stone-Fuller.
Really glad that you're here. I'm going to spend a little time today talking about this concept called Gaia and how it relates to a very difficult topic to talk about, and that is abrupt climate change. And I want to apologize to everyone right up front for some of the bad news that I'm going to give you today. But fortunately, there's a lot of really interesting, what I consider to be good news up front. We're going to go through that first. A little bit about myself. My full name is Alder Stone-Fuller. I have one of those people that spent too much time in university. Spent from about 1968 to 1973 working on my bachelor's degree in biology at University of Memphis. From there I did 2 master's degrees, one in a field of biology called systematics, and a second one in probability theory, also in statistics. And after finishing those, I worked on my doctoral studies at University of New Mexico. Finished that in 1990. And when I finished, I was already older than most of my committee members at the school. I studied ecology and evolution at University of New Mexico. After that, for about 8 years, I taught community college mostly at a small school in Albuquerque, Central New Mexico Community College, where I taught biology and math full-time. And after that, I migrated up to the Pacific Northwest, where I taught independently as a college-level teacher, teaching many of the ideas that I'm going to tell you about today. A set of new sciences called systems sciences, and a related branch called geophysiology that I'll tell you about later on. In summer of 2010, I left the West Coast, which is where I was, and moved to the state of Maine, which is where I am now, living currently in Skowhegan. I'm still teaching independently, and at the current time I'm moving between cities in central and southern Maine, teaching these ideas. And this presentation that I'm going to give you today, share with you today, is the core of my program. It's sort of the portal into everything else that I do. So it's a pleasure to be here, and I'm really glad that you're all here. Oh, by the way, my website is alderstone3.com. I'll mention that again later. This that I'm talking about today is an hour-and-a-half to 2-hour overview of a 10-hour seminar. I'll actually be presenting the seminar in various places around Maine over the next year. And it's also the core, the very core of my program and the entryway into it. This lecture has what I refer to as a light side and a dark side. The first part is 3 parts of this lecture. First part deals with a new set of sciences called system sciences or network sciences. I'll explain what that means shortly. And then the second part deals with what we call Gaia theory and the science of Gaia called geophysiology, and I'll be very clear in a few moments what I mean by Gaia. And the third part deals with what we call, in climate sciences, we call type 2 climate change. That is abrupt and chaotic. And unfortunately, this will change the course of civilization, and it probably literally will turn Earth into a different planet by 2050. It'll still be Earth, but it's going to feel and look like a different planet. Now, these first 2 parts are what I call the light side. They're very well established in the sciences, have been for several decades, and it's the core of the ideas that I teach. The other part here, part 3, is what I call the dark side. It's not as much fun, and yet I think that we definitely need to understand these ideas if we're going to deal with, effectively be prepared for what's coming our direction. Now, have any of you ever seen the film called Matrix? If you saw Matrix, then, especially Matrix 1, then you'll relate to this slide or this image. This is Neo about to accept or choose between the red pill and the blue pill that Morpheus is offering him. What I'm offering you today is the red pill. The blue pills are in a little can by the door as you go out if you want to erase all of this and go back. But I'm offering you what I consider to be the truth about climate change. And you can't get this in many other places. So we're going to start with science because this seminar, this lecture in the seminar, Gaia 101, is grounded in sciences. During the seminar itself, the 10-hour seminar, I talked first about the science as a way of knowing. It's just a tool that we can use for understanding how things work. We talk about how science differs from the knowledge learned by science, which is what you generally study in a physics or chemistry class. You learn the knowledge learned by science, and that differs from the science as a process. And also I distinguish between the use of that knowledge and technology. Once we learn science, learn some knowledge through science, it doesn't mean that we have to use it in any particular way. Technology decides how the knowledge will be learned, how the knowledge will be used, rather. I also talk about the distinctions between science, philosophy, religion, and pseudosciences. If you want to ask questions about that later, I can answer them for you. We talk about definitions and basic processes of science, how we use observations and questions, hypotheses and predictions, and hypothesis testing. That's the core of how we've learned all this information that I'm going to share with you today. And then we also talk about theories and models and something called scientific paradigms. Paradigms being sort of the overarching collection of ideas that are current in science at any given time in history. So I want to talk about two paradigms of science. This first one called mechanistic reductionism, that's the fading paradigm. It's on the way out now. And system sciences is the new paradigm. I'll talk about that next. Mechanistic reductionism was the dominant Western science paradigm of the last 300 years. It was also sometimes called the Newtonian Cartesian model, named after Isaac Newton and René Descartes, starting in about 1670. The metaphor for this paradigm of science was the machine, a clockwork machine. And the clocks were the only kinds of machines present in Isaac Newton's day. And so they thought everything in the universe was a big clockwork mechanism. And it's still with us today, this metaphor of a machine. There's sort of two premises, assumptions underneath this mechanistic reductionism. The first is that that in order to understand the machine, you dissect it and study its parts. You take it apart and study the parts, and if you can understand the parts, then you can understand the whole machine. That's the first premise. The second one is that nature is linear, and therefore it is predictable, and therefore it is controllable. Now, I'll to help you understand more later about what I mean by linear. But linear systems are very predictable and very controllable as a result. Some examples of mechanistic sciences are classical physics and chemistry, biochemistry, cell biology, human anatomy, astronomy, geology, oceanography, atmospheric sciences. Virtually everything that's studied in university today falls into the realm of mechanistic reductionism. As a biology teacher who's taught anatomy and physiology, I know, for example, that anatomists talk a lot about machine-like parts that we're made of. The heart is considered to be a pump. Blood vessels are considered to be pipes. Kidneys are filters. The brain is a computer. This idea of mechanism is shot through in anatomy. Now, let's contrast that with the newer paradigm that's coming on in the sciences for about the last 30 years or so, called the systems sciences. Really began in about the 1970s. They can also be called the network sciences or the complexity sciences because they deal with things that are complex, complex parts that interact with each other. I'll give you some examples shortly. What the system sciences recognize is that reductionism, taking things apart to study the parts, is necessary, but it's not sufficient. It's necessary to understand a system, but you can't understand the system by reductionism alone. You've also got to study the entire system as a whole. And I'll tell you more about why later on. The premise also is that nature is non-linear, and therefore it is largely unpredictable, especially over long time periods, and therefore it's fundamentally uncontrollable by humans. We can do what we can, but for the most part, we understand now that we can only go along with nature, not necessarily control it to make it do what we want it to do. As a result of being nonlinear, there's some pretty cool images, some of which I'll show you later on. This is an image that comes from a very famous simple nonlinear equation. I'll talk more about that later on. And the cool thing about system sciences is that once you understand the principles, they apply to any kind of system on any scale, no